So here we're going to be looking at exponential functions. And then if we look at exponential functions, we did exponential functions last year. They were defined by f of x, which is given by a multiplied by b to the power of x plus q. This is what we did last year. And then this is what we said last year. We said the following. Let's just remember what did we say? We said the value of b is always going to be greater than 0. B should be positive. Why do we want b to be positive? If we make, like, for example, let's consider b to be negative. If you make b to be negative here, and then you have something that looks like this. Look at the following here. And then you have y, which is going to be equaling to minus 2 to the power of x. Okay? And then you put 1 here. Again, like, we can change values of x. If you put 1, then check what is happening. You are going to get minus 2 as your answer. Again, if you put 1 here, you're going to get minus 2. Ne? And then if you put 2, but look at what is happening. If you say minus 2 all squared, type something like this in your calculator and see what you get. What does it give you? It gives you 4. Okay? Now you have a situation whereby you have a negative and then you have a positive, which is what something like this. Your points are going to be like positive, negative, depending on whether you are raising this thing to the power of an odd number or you are raising it to the power of an even number. So it's not an exponent anymore. It doesn't become an exponent anymore. So b should be greater than 0. That's one of the restrictions. What is the second restriction? The second restriction is that b should not be 1. B cannot be 1. Now, why don't we want b to be 1? Let's consider the following here. Why is it that we don't want b to be 1? If we say y is going to be equaling to, and then we put b as 1 to the power of x, okay? Now, any number, 1 raised to any number is still going to give you 1, okay? And then it means you're going to have something like that looks like this. You have 1 here, and then you're going to have a straight line. This is not an exponential anymore. So, what learners need to remember is that we have f of x, which is given as a, b, x, plus p plus q. We have a and then we have b. A can be negative, b cannot be negative. A can be 1, b cannot be 1. That's what you should remember. So if we come and check the following here, look at the following here. When you see this negative here doesn't represent negative of a, it's the negative of what? Of a. And then we already know a now. A gives us the shape of a graph again. The job of a, we've seen it with parabolic function, we've seen it with a hyperbolic function. It just determines the shape. So if you look at this equation here, it means you are going to have y, which is going to, if they ask you what is a, you're going to say which a is going to be minus 1. And then if they ask you what is going to be b is going to be 2. And then if they ask you what is going to be q, you're going to say which q is going to be equivalent to what? To 2. Again. And then if they ask you what is going to be p, what is going to be p here? 1. Okay, let's take the following equation here. If they ask you what is going to be a, what is going to be your a then? Your a is going to be 1 all over 2. What is going to be your b? Our b is what? It's 2, okay? And then what is going to be c? And what is going to be q, man? It's minus 1. And then what is going to be our p then? Are we together then? Let's look at this one here. If we look at this one here, what is going to be our a? It's noted. What is going to be our a here? A is minus 1. What is b? B is going to be equivalent to 2. What is q? Q is going to be 0. And then what is going to be p? 1. Okay, my Ben. What do you want to say? Where here? Yeah, I'm saying this thing here, like you should be careful here, guys. Here, there are two values here. There's a and then there's b. Ne? What you see here, it looks as if p is negative. P will never be negative. I'm telling you now. We just saw why p should never be negative. Okay? So what you're going to have when you're going to have a situation like this, you're going to have minus 1, open bracket, and then you have b, and then you have x plus 1, and then you have plus 2. So the p is positive. You see that again? So what is the difference between p being negative and a being negative? If you have p being negative, it means that you have minus 1 inside. Minus 1 is not inside, it's outside the minus 1, it's outside the bracket. So the 2 is always going to be positive. So you have a positive 2 here. Are we good there? So now that we understand that part, I think that's the part which is a little bit confusing for learners, because you see what Lebogang was saying, it seems as if the P is negative, okay? But there's not P there, there's P and A. That's what you should remember. The A is outside the P. Okay, with that being said, then let's get to today's work. What is it that we want to do then? We want to do everything that we've already done before. We want to talk about the asymptote. We want to talk about the x-intercept. We want to talk about the y-intercept. We also want to draw this graph. So how are we going to do that? I am going to take number C, and then I will ask you to take number F as a classwork, and then we are going to do number H, and then we're also going to do number I as a homework. Now let me take number A and number C. If we take number C, according to number C, the first question says determine the equations of the asymptotes. Now here's what you need to know about exponential function from last year. Exponential function has one asymptote. An exponential function has one asymptote. Unlike the hyperbolic, every hyperbolic has the vertical and the horizontal. An exponential only has one. So I will say number C, number one. If they ask me what is going to be the asymptote, whatever the value of Q is going to be our asymptote. Agree we don't have any denominator here. For the fact that we don't have any denominator, we're only going to have one asymptote. Our asymptote here is going to be equal to what? Y is going to be equal to -1, whatever the value of Q is. So we don't have the vertical one, we only have the horizontal one. We're still fine. Yeah. Okay, number 2, they say which I should determine the y-intercept. Nothing has changed. How do you determine y-intercept? We should make x to be equal to what? To C. Then we're going to say we have y, which is going to be given as 2. Instead of x here, what am I going to put? I am going to put 0 plus 2 minus 1 again. And then if you type this in your calculator, what do you get? 3. You get 3. Then you have 0, which goes with what? With 3. Are you still fine? You type this in your calculator, change exactly the way it is. You are going to have 2, and then you have 0 plus 2. And then you have -1. It gives us 3 again. Okay. What else do we know? They asked us which we should determine the x-intercept. Nothing has changed. You still know how to get x-intercept. Okay? How do you determine x-intercept? So I am going to say I have 0, which is going to be equal to 2 to the power of x plus 2 minus 1. Okay, what am I going to do here? I'm going to take this one to this other side. Okay? If I take this one to this other side, what am I going to have? 1 is going to be equal to 2x plus 1. Or plus 2. Now, I want to make this base to be 2 again. How do I make this base to be 2? I'm going to say 2 to the power of 0 is going to be 1. Again, any number to the power of 0 is 1. Then 2 to the power of 0 is going to be 1. Then I'm going to have 2x plus 2. Now, bases are equal again. If bases are equal, what are you going to do to the exponents? You drop the exponent. Then it says which is 0 is going to be equal to x plus 2. Take this one to this other side again. If you take this one to this other side, what are you going to have? Minus 2, which is going to be equal to what? X. We're able to get the equation of the asymptote, which is y minus 1 again. And then we got the y-intercept, which is 3 and 0. We got the x-intercept as -2. Now that we know how to get all these things, we are ready to draw our graph. Then we can go and draw our graph, indicating where it intercepts with the x-axis, and then we're also going to show the asymptote. So if we do have an asymptote, we are going to start there. So if we go to our asymptote, they say our asymptote is -1. And then we'll start here and say here we have on -1, this is y minus 1, and then we'll just do a dotted line. Okay, and then we say which here this is y is going to be equal to -1. Now this is what you need to understand about this graph here. This graph here will not go beyond -1. So -1, it's a fence. It cannot go beyond -1. So in other words, they are going to ask us something about the range. When they ask us about the range, we know that this graph here is not going to go anywhere. After -1, there's no graph. You're not going to see any part of the graph because you have -1 as your asymptote. Now we are going to represent the x and the y-intercept, we have 3 and then we have -2. So let's go and put those two. So -2 is here. So they gave this one as -2. So this is 1, this is -2, or this is 3. -3, this is 2. So we'll come and say, okay, here we have our -2. And then we have our y. What did you get as y?
3.
What did you get as y?
3.
3.
Yes.
We got y as 3. And then our asymptote is -1. Okay. So we'll come and say here we have another intercept here at 3. And then after this, we're going to draw our graph. Now, how do we draw our graph? Usually, now what we do is to put it on a table. We're going to type this thing on our table. So we go to table. And then we're going to type that thing exactly the way it is. It says which we have x, we have 2. And then we have alpha, and then, we have exponent. We have 2, then we have exponent, then we have alpha, x. It says plus or minus?
Plus.
Plus 1.
Minus.
And then it says minus
Plus 2.
plus 2. Okay, it's plus 2. And then it says minus?
-1.
Minus 1. Equals 2. And then if they ask us which way do we want to start, we just start here at -3. We want to include everything.
Yes.
Just after the 3. So we'll have -3. And then if they ask us where do we want to stop, I can just stop here. Just after this. And then I'm going to have 1. And then this is what I have here. They say which one is -3, I have 0.5. -3 is 0.5 there. And then -2 goes with -2 goes with 0. No? Okay, here it is then. Then I can connect these two. And then
-1 and 1.
it's -1, it goes with what?
1.
It goes with 1. Here it is here. And then you can connect this one.
0 and 3.
And then 0 goes with 3 here.
1 and 7.
And then 1 goes with what? With 7. Let me put this correctly. So here we have this one which goes with this one. And then we are going to have something that passes through here. And then it's going to approach this line. Remember, we can't touch this line again. Yeah, and then because I don't have any 7 here, I'll just say this thing here is going up there. So it's going to be something that looks like this. And then as your activity, you know your activity.
Yes. Yes, I have to